So they are all constant. So we got one of them. Let's look at a case where the coefficient is a variable. So by this, we have to determine the region of all points at which the PDE is hyperbolic and sketch the region. So from here, what is our A? Our A is y, b plus negative x minus y, and I can write it as y minus x, and our c equal negative x. So the discriminant, which is b squared minus 4ac, is equal to y minus x all squared minus 4 times y times c, and this is going to give us y minus x all squared plus 4xy. If we expand and simplify, we're going to get y squared plus 2xy plus x squared, which can be written as x plus y all squared. Now, because of this square, there's no way this should be less than 0. It can never be negative. So it can only be 0 or greater than 0 because of the square here. So this is the discriminant, but we can't simply conclude on the case why we know it's definitely not elliptic anymore. So let's see. We need to sketch this function by setting it equal to 0. So we assume that equals 0. So we are first going to state that if x plus y all squared is equal to 0, meaning if it is parabolic, we're going to get x plus y being equal to 0 and y equals negative x. So let's sketch this function as you see there. First, it's not part of it. We have an x and y as. Now the line y equals negative x is this line. And this line, you have to draw it first because that's for the line you're going to use to split the domain of the function into two parts or more, depending on the number, the type of function we are dealing with. So this one has shifted this one up and this one down. Now all that we need to do is to pick a point here and a point here and test whether that point will be greater than 0, as we are to verify whether it is hyperbolic. So let me say I'm picking the point 1, 1, which is here. If you put it inside the discriminant, we're going to get 1 plus 1 squared, which is 4, and it's greater than 0. So we can see that all this part, the equation is hyperbolic. Now let's pick a point here, let's say negative 1, negative 2. So the descriptor of negative 1, negative 2 will become negative 1 minus 2 all squared, which is going to give us 9 greater than 0. So we can also say that in here the equation is also hyperbolic. So we can put it in the simple terms as this. That is, we have so if this is equal to 0, if then y equals negative x. So and this equation is parabolic on this line. Now we realize that if it is greater than 0 or less than 0, it's hyperbolic. So if x plus y all squared is greater than 0, you're going to have y to be greater than negative x. If x plus y squared is less than 0, we're going to have y to be less than negative x. In all these two cases, the equation is hyperbolic. So we say that, we conclude by saying the equation is hyperbolic everywhere except on the line y equals negative x. Let's look at another example. Our A is y, B is negative 4, and C is 4x. So the discriminant is equal to b squared minus 4ac, which is 16 minus 4y and 4x, and this will give us 16 minus 16xy. So in the same procedure, we let's assume it's equals to 0. So we are saying that if the equation is parabolic, then we are going to have 16 minus 16xy being equal to 0, and that means 16xy equal to 16, and you get y to be 1 over x. So we sketch this curve, and if you are not forgetting your curve sketching, you realize that you're going to get something like this and something like this. X, the line y equals x equal to 0 is the horizontal, the vertical asymptote. So you have the curve like this. Now you want to look at the arterial regions. So the curve is like this and that. The arterial regions here, here, and here. And we want to determine which of the region satisfy the inequality. But we know on this line the equation is parabolic. So what about here? So let's pick a point here. Let's just say 2, 2. So if you compute the discriminant of the 2, 2, we are going to get 16 minus 16 times 4, which is going to give us a negative number, because